What did it mean to believe you could put an aircraft carrier in the sky? In an era when ocean fleets vanished beyond the horizon, America dared to fill the void with flying aircraft carriers, rigid airships the size of battleships, intended to scout 200 miles ahead and change naval warfare forever. In 1928, Rear Admiral William Moffett convinced Congress to sign a contract that would spend millions in pursuit of this audacious dream. These were precision-engineered giants, armed with onboard fighters and containing 6.5 million cubic feet of helium. They were designed with the confidence of engineers and the weight of national strategy. But why did these carefully tuned machines vanish in barely a decade? This is the story of technology's boldest promise and its silent disappearance. War planners in the 1920s faced a simple equation with devastating consequences. The Pacific stretched beyond the reach of even the most advanced carrier aircraft, leaving a gap between what the Navy could see and what it needed to know. Carrier-based planes of the era could scout just 100 nautical miles ahead, barely half the minimum distance required to detect an enemy fleet before it could strike. Naval doctrine demanded eyes at least 200 nautical miles out. Anything less risked surprise attack, lost battleships, and the collapse of entire fleet formations before a shot could be fired. Tactical memoranda from the Bureau of Aeronautics spelled out the problem in cold numbers. At 20 knots, a battleship could close the distance from the horizon in hours. War games and fleet exercises exposed the blind zone again and again. Reconnaissance planes ran out of fuel, lost contact, or returned with only partial sightings. Surface scouts, bound by the curvature of the Earth and the limits of radio, could not fill the void. The math of survival was unforgiving. Without a way to extend the Navy's vision, the fleet itself was exposed, its fate measured not in firepower, but in the empty miles beyond the horizon. The requirement was clear. The Navy needed a scout platform able to patrol 200 nautical miles ahead, persistent enough to outlast the enemy, and fast enough to report back before disaster struck. William A. Moffett understood that technology alone would not fill the empty miles between the fleet and the unknown. As chief of the Bureau of Aeronautics, he spent years in Washington's committee rooms translating the Navy's urgent need for long-range eyes into language Congress could not ignore. Moffett's advocacy was relentless. Between 1925 and 1928, he appeared before appropriations hearings, drafted memos, and pressed for airship funding even as skeptics questioned the wisdom of floating giants in the sky. He pointed to the lessons of USS Shenandoah and Los Angeles, proof that rigid airships could endure, patrol, and return with intelligence no surface ship could match. The breakthrough came in 1928. After 3 years of political maneuvering and technical debate, Congress awarded a contract to Goodyear Zeppelin, a partnership blending American resources with German experience in rigid airship design. The contract authorized the construction of 2 helium-filled airships, each intended to carry scout planes deep over the horizon. Moffett's vision was now tangible, no longer just a line in a memorandum, but a funded program with steel, aluminum, and helium soon to follow. The ink on the Goodyear Zeppelin contract signaled more than a procurement. It was a rare victory for a single advocate's persistence, turning the theoretical promise of extended fleet reconnaissance into hardware that would soon challenge the limits of engineering. The path was clear for the designers and builders to attempt what had never been done on American soil. Steel latticework and duralumin ribs stretched across 785 feet, forming a hull longer than the largest ocean liners of its day. The Akron and Macon each carried within their frames a volume of over 6.5 million cubic feet of helium, held in a series of gas cells that pressed outward against the rigid skeleton. This immense lift allowed the airship to rise with a useful load of nearly 100,000 pounds, enough to carry not only its crew and equipment, but an entire aerial detachment of scout planes and their support. 8 Maybach engines, each producing 560 horsepower, were mounted deep inside the hull to reduce drag. Their combined output drove the airship through the sky at a cruising speed between 57 and 63 miles per hour, with the possibility of reaching 80 miles per hour at full power. At 12,000 feet, the airship could maintain station above the weather, its aluminum skin reflecting the sun, while the world below faded into cloud and haze. Life aboard demanded a crew of 60 to 80 men, from pilots and mechanics to radio operators and meteorologists. The airship's internal spaces were a labyrinth: catwalks, control cars, engine rooms, and a cavernous hangar for the parasite aircraft. Endurance was measured in days, not hours. With a full load of helium and fuel, the ship could remain aloft for more than 10,000 miles of continuous patrol. Every dimension, every calculation, was an answer to the Navy's demand for reach and persistence, a machine built to outlast the horizon and to bring back knowledge from the edge of the unknown. Inside the Akron and Macon, the hangar stretched 110 feet along the spine of the ship, an aluminum cathedral suspended in helium. This space held up to 5 Curtiss F-9C Sparrowhawks, each a compact biplane stripped to essentials, with a 20-foot wingspan, a single pilot, and a hook fixed above the upper wing. These planes hung in silent rows, ready for launch or retrieval at a moment's notice. The heart of the system was the trapeze, a steel arm lowered through the belly of the airship, dangling 30 feet below the hull. When a launch order came, the hangar doors slid open, and the trapeze descended into the slipstream. A Sparrowhawk, engine running, was wheeled into position and attached to the bar. With a signal from the crew, the pilot released the hook and dropped into open sky, the airship moving at 38 to 45 knots to smooth the transition. Retrieval was even more delicate. The pilot approached from below, matching speed and altitude with the massive shadow above. At just the right moment, the hook snapped onto the bar, and the winch drew the plane up through the wind. The entire process, approach, latch, and retraction, could take as little as 20 seconds, but a gust of wind or a moment's hesitation risked disaster. Docking trials logged every second, every shock load. Test pilots described the maneuver as flying into a moving barn, with the airship's slipstream buffeting the fragile biplane. Procurement ledgers recorded the ambition in cold numbers, each airship costing between $6 million and $8 million, a staggering sum in Depression-era America. Every launch and retrieval pressed the limits of engineering, and every successful hook-on was a small victory against the laws of physics. Yet beneath the precision and spectacle, each cycle left invisible scars, stresses accumulating in the latticework, quietly tallying the price of innovation. April 4th, 1933. Over the Atlantic, just off the coast of New Jersey, the USS Akron met its end in darkness and storm. Winds above 50 miles per hour tore at the airship's hull. Sheets of rain and ice hammered the frame, coating the tail with a heavy crust. In the early hours, a sudden gust forced the Akron's tail downward. The stress proved too much for the duralumin girders. The structure snapped and the great ship plunged toward the sea. Of the 76 men aboard, Only 3 survived the night. Rear Admiral William Moffett, the architect of the Navy's airship vision, was among the 73 lost. Survivors clung to wreckage in freezing water for 12 hours, while the rest disappeared beneath the waves. The Court of Inquiry found that the tail girder failed under extreme wind and icing, leaving the Akron with no chance to recover. America's ambition for the sky was now measured in lives lost and steel twisted by the storm. On February 12, 1935, the USS Macon drifted above the Pacific near Point Sur, California. Without warning, a sudden gust tore through the midsection, snapping the girder that held the ship's spine together. Helium hissed from ruptured gas cells as the airship sagged and began its slow descent into the waves. 2 crewmen lost their lives. 74 others survived, plucked from the cold water. The Navy's inquiry traced the failure to a weakness in the midship structure, a flaw known since the loss of Akron, left uncorrected as budgets thinned and priorities shifted. Congressional hearings followed, but the arguments for airships had already faded. The cost of helium, the slow pace of repairs, and the growing confidence in fixed-wing aircraft turned support into silence. By the end of 1935, the program was canceled. The vision of flying aircraft carriers, once measured in blueprints and ambition, was now confined to the wreckage on the ocean floor and the silence of abandoned hangars. Today, the empty hangars at Moffett Field and rows of twisted aluminum in the Pacific mark the boundary between ambition and reality. As unmanned drones redefine air power, the dream of a sky fleet serves as a reminder. Some futures vanish, but their questions still shape the horizon.